All right, so that leads us to what we want for a one-way ANOVA test, analysis of variance test. So there have to be k simple random samples, one from each of k populations. The k samples are independent of each other. That is, the subjects in one group cannot be related in any way to the subjects in a second group. Oops, sorry. The populations are normally distributed, and the populations have the same variance. So you can see for the second one right here, the second picture we said was stronger evidence, that has same variance. The top one doesn't. So we want them to have the same variance, i.e. the same standard deviation. Okay, actually proving the variances are the same can be really tricky. But a general, well, you can make Excel do it for you sometimes. But anyway, but a general rule of thumb is that the largest sample standard deviation is no more than twice the smaller sample standard deviation. Okay, so let's do a couple things. First of all, we're going to verify all our requirements and see if we understand what they were all saying. So I'm going to write them down a little bit up here. Okay, requirement number 1 was that there were k simple random samples for from k populations, right? Well, we totally have that. So yes, we have that. We have 3 simple random samples. They took 3 samples from each population, right? The Muzak population, the advertisement population, the classical population. Done. All right, requirement number 2 was, let's see, go back up. The k samples are independent of each other. K samples are independent. I'm not sure I spelled that right. In fact, I'm sure I didn't. Independent. There we go. All right, so yes, we have that as well, because whether a person waits on the phone with an advertisement, oh my goodness, has no effect on someone else's waiting time for anything, for Muzak or advertisements or whatever. All right, number 3, normally distributed with no outliers. Okay, that's why they gave us these pictures. So these pictures I made from Minitab, and you can see all of them are normally distributed. So yes, normal with no outliers. See pictures. I can just say that. Yes, see pictures. Right, they're normal, they have no outliers, life is grand. Step 4, the populations have the same variance. That's actually a really complicated thing, and we're not going to get into it too much. All we're going to do is what they said, which is the sample standard deviation is no more than twice the smallest sample standard deviation. So let me write it out. This is not a formal test. There is a formal test for it, and we're not doing it because it's long and involved. Okay. As a matter of fact, it's beginnings of section 11. 4, if you want to go back and look at it. So we're going to find the standard deviation for each of these groups. So I'm going to go do that with Excel, and I'll be right back. Oh wait, I don't need to. Here are the standard deviations right here. Hold on. I could go find them with Excel if I wanted, but I'm not going to bother. I'm just going to put them in. Okay, so there are the standard deviations for the different groups. So the largest standard deviation is equal to 4.2 is not, what do they want? No more than twice the smallest sample deviation. Okay, so twice the smallest, let me put it this way, 2 times the smallest is equal to 2 times 2.4, which is equal to 4.8. And so we're okay because 4.2 is smaller than 4.8. It can't be more than 4.8. That's just a rough rule of thumb. All right, so we've verified all those requirements.